Welcome to this deep dive. We're jumping straight into the fascinating world of the late Cretaceous in Asia. Today we're looking at a really interesting dinosaur, Bagaceratops.
Bagaceratops, yeah. And the name itself tells you something right off the bat. It basically means small horned face.
Right, from Mongolian Baga for small, and then the Greek Ceratops for horned face, which pops up a lot in dinosaur names.
Exactly. A very fitting description, as we'll see. This creature was around, about 72 to 71 million years ago, so late Cretaceous.
And firmly in Asia, yeah.
Yeah,
The fossils are mostly from Mongolia.
that's right. Specifically places like the Gobi Formation and the Bayan Mandahu Formation. There's maybe some evidence from Udan too, but mostly those first two.
Got it. And for this deep dive, we're really leaning on the scientific papers, aren't we? The discovery counts, classification studies, paleoecology.
Precisely. The published research is our guide here.
So our sort of mission, if you like, is to figure out what Bagaceratops tells us about the diversity, the evolution of these early horned dinosaurs just before things really changed at the end of the Cretaceous.
Yeah, it occupies a really interesting spot in that story.
Okay, so let's unpack this. Where did we even first learn about Bagaceratops? What's the discovery story?
Well, the story really gets going back in the 1970s. There were these major Polish-Mongolian paleontological expeditions.
Oh, yes, those were hugely important, weren't they?
Absolutely. They were incredibly successful. And one site, Herminsov in the Gobi Desert, was just packed with fossils of these early horned dinosaurs, these protoceratopsids.
Wow. Just imagine finding that richness of fossils.
It must have been incredible. And it was two Polish scientists involved in those digs, Mariaska and Osmolska, who formally named Bagaceratops Rozdestvensky in 1975.
Okay, 1975. And what was it based on initially?
Their description relied on a decent amount of material, but the key specimen, the holotype, is a medium-sized skull. It's cataloged as ZPL MGD-I-126.
ZPL MGD I-126.
Yeah.
Got it. And the Rozdestvensky part of the name.
Ah, that honors Anatoly Konstantinovich Rozdestvensky, a prominent Russian paleontologist. A nice nod to his contributions.
Right, so that laid the groundwork. But, like with many fossil discoveries, the picture gets clearer over time, right? More finds must have followed.
Definitely. Fast forward to 1993, and you have a joint Japan-Mongolia expedition. They found something quite special at Herminsov as well.
Oh, what was that?
An articulated, nearly complete skeleton. Specimen MPCD 10535.
Nearly complete. That's amazing.
It is. And, interestingly, while it's been looked at for things like tiny boreholes left by invertebrate scavengers after death, the full formal scientific description of the skeleton itself was, well, still largely pending as of 2019. It's kind of surprising, actually.
Huh. So a major piece of the puzzle potentially sitting there, not fully published yet. That is interesting. But other finds have been described more recently.
Yes, exactly. In 2019, there was a description of another partial skeleton, KED-196, also from Hirainsav. So the work continues.
And what did that 2019 find tell us?
Well, the study by Kim and colleagues noted that the postcranial skeleton, so everything but the skull, looked generally pretty similar to Protoceratops.
Okay, it's close relative.
Right. But they also pointed out some key differences, specifically in the skull and also in the shape and even the position of the clavicles, the collarbones.
So subtle but important distinctions were emerging, reinforcing its uniqueness compared to Protoceratops.
Exactly. And then, even more recently, a 2020 study by Chipieski looked at some other specimens, including some from potentially different areas or formations, like Udan and Zamin-Kond.
Okay.
And one particular specimen, MPCD 130551B, raised a really fascinating possibility. It looked like it might represent an anagenetic transition.
Anagenetic transition. Explain that a bit.
It's basically the idea that one species gradually evolves into another over time in a sort of linear fashion without a branching event happening.
So not splitting into two species, but one slowly morphing into the next.
Sort of, yeah. And the suggestion here was that this specific fossil might show traits intermediate between Protoceratops and Drisi and Bagaceratops rojdestvensky.
Wow. So potentially catching evolution in the act, showing a direct lineage.
That's the intriguing implication, yes. A potential snapshot of that process. Now, this also connects to another complex area, synonyms.
Ah, the classic paleontology puzzle, where multiple names might actually refer to the same animal.
Precisely. It happens a lot as more fossils come to light and our understanding grows. Initially, several other names were proposed for similar-looking ceratopsians from the same rough time and place.
Like what? What names were floating around?
Well, you had Gobiceratops minutus, Lamasotrops terrashenkoi, Platyceratops tatranovi, and also one called Megnirostris studsoni. For a while, these were treated as separate types of dinosaurs.
That's quite a list. What made scientists think they might all be Bagaceratops?
A key moment was in 2006 when Makovicky suggested they were likely junior synonyms. He argued that the features used to define them could actually be seen in known Bagaceratops specimens.
So maybe just individual variation or different ages.
Exactly, or even just differences in how the fossils were preserved, squashed or distorted slightly. It highlights how tricky it can be to interpret fossil features.
Definitely. Did later research support that idea?
Yes, very strongly. Łukasz Czapieski, in that big 2019 study we mentioned, did a really thorough re-examination. He looked at the original holotypes of Gobiceratops, Mini-Ceratopsian, Platyceratops, and Megnirostris, plus lots of other Bagaceratops material.
And his conclusion?
His conclusion was that, yes, all those features fall within the expected range of variation for a single species, Bagaceratops rojdeśvinski, accounting for individual differences and changes during growth from juvenile to adult.
So Gobiceratops, Mini-Ceratops, Platyceratops, Megnirostris, all likely just different phases or ages of Bagaceratops. That simplifies things a bit.
It certainly does. It suggests Bagaceratops was perhaps more variable in appearance than initially thought.
What about Bravaceratops? Sometimes that name comes up in these discussions too. Is that also a synonym?
Ah, good question. Bravaceratops is a bit different. It was also named from remains found in Mongolia, initially even thought to be a type of Protoceratops. For a time, some researchers wondered if it might just be a juvenile Bagaceratops.
Okay.
But the current consensus, again heavily supported by Czapieski's analysis, is that Bravaceratops is actually a valid, distinct genus. It has its own unique mix of primitive and more advanced features compared to both Bagaceratops and Protoceratops.
Okay, so Bravaceratops stands apart. So with all this sorting out done, where does Bagaceratops officially sit in the grand scheme of classification?
Right, so working down the hierarchy, domain Eukaryota, kingdom Animalia, phylum Chordata, then Dinosauria ornithischia, the bird-hipped ones, Coronosauria, which includes most horned dinos, and then the family Protoceratopsidae, and finally genus Bagaceratops.
Protoceratopsidae, the family of early horned dinosaurs. And within that family, how does it relate to the others, like Protoceratops and Bravaceratops?
Czapieski's phylogenetic work suggests a specific pattern. He places Protoceratops andrewceras as the most basal member, the one that branched off earliest.
Okay, the earliest branch.
Then you have a group containing Protoceratops helenicorhanus and a smaller group, a clade, that includes both Bravaceratops and Bagaceratops.
So Bravaceratops and Bagaceratops are quite closely related.
Yes, very closely related, according to this analysis. And interestingly, in this specific arrangement, Bagaceratops actually comes out as the derived most member of the whole Protoceratopsidae family.
Derived most, meaning it had evolved the most changes compared to the ancestral form of the group.
That's the idea, yeah. It suggests it was perhaps the most specialized or had accumulated the most unique traits within that particular family lineage, at least based on the features analyzed.
Interesting. Okay, let's shift to the animal itself. What did Bagaceratops actually look like? You said small horned face. How small are we talking?
We're talking pretty small for ceratopsians, especially compared to the later giants. Lengthwise, maybe 1 to 1.5 meters.
So about 3 to 5 feet long, like a medium-sized dog, maybe a bit bigger.
Yeah, something in that ballpark. And weight estimates, often using the Megnirostris material, which was a bit chunkier, are around 22 to 45 kilograms.
50 to maybe 100 pounds, definitely not huge.
Not at all. And as we sort of touched on, its overall anatomy, while living quite late in the Cretaceous, still had some relatively primitive features compared to the later big ceratopsids like Triceratops. It kept that smaller body plan.
Right. What were some specific features that set it apart, especially from its close relative Protoceratops?
Well, one key thing is the teeth at the very front of the upper jaw, the premaxillary teeth. Protoceratops had them, these sort of blunt, peg-like teeth. Bagaceratops didn't. It lacked those premaxillary teeth entirely.
Okay, no teeth right at the front beak. What else?
Its nasal bones, the bones forming the top of the snout, were fused together. And another interesting feature is in the maxilla, the main bone of the upper jaw. Bagaceratops had an extra opening there, an oval-shaped window called the accessory antorbital fenestra.
An extra hole in the skull. So fused nasals, no front teeth, extra skull opening. These seem like pretty clear diagnostic features.
They are, yes. They help paleontologists distinguish it, even from fragmented remains sometimes.
Okay, so we have a picture of this small beaked dinosaur with some unique skull features. Now let's place it in its world. What was the environment like where Bagaceratops lived? You mentioned the Barrangoyor Formation.
Right, that's where most of the fossils come from. Geologically, it's dated to the Late Cretaceous, the middle to upper Campanian stage.
And what kind of landscape does the rock tell us about?
The rocks themselves are things like red beds, reddish sandstones and mudstones, plus lighter sands, conglomerates. It paints a picture of alluvial plains, so areas built up by rivers, maybe some lakes, but also quite a bit of aeolian or wind-blown sediment influence.
Dunes, maybe.
Yeah, dune fields were likely part of the landscape. And the overall climate seems to have been relatively dry, arid to semi-arid.
A dry, perhaps sandy or dusty environment with some rivers and lakes. And Bagaceratops was common there.
Extremely common. It's actually the most frequently found dinosaur in the Barun-Goyot Formation.
Wow, so it must have been doing quite well for itself in that habitat.
Seems like it. And it wasn't alone, of course. It shared that environment with a whole host of other creatures.
Oh, yeah. Like, give us a sense of the neighborhood.
Well, you had armored dinosaurs, the ankylosaurids, names like Cychania, Tarkia, Zarapelta, very tank-like animals.
Right.
Then small, fast, possibly insectivorous alvarezsaurids like Coulcinurus and Parvicursor. Lots of early birds, Gobi, Gobipteryx, Hollanda. Its close relative Bagaceratops was there too.
Okay, quite a mix already. Any predators?
Oh, yes. Dromaeosaurids, the raptor dinosaurs like Kuru and Shri, a strange one called Holson peas. Bone-headed dinosaurs, pachycephalosaurs like Tylosophil.
And the Oviraptorosaurs,
No.
those parrot-beak dinosaurs.
Plenty of those. Conchoraptor, Heywania, Nemegtomea, even a big long-necked sauropod, a titanosaur called Quasitosaurus, roamed the area. Plus, lots of early mammals, lizards, snakes. Quite the community.
That's an incredible snapshot. A
Yeah.
really diverse fauna living alongside Bagaceratops. Now, what about the other main site, the Bayan-Mandahu Formation? Similar story there.
Broadly similar, yes. Also late Cretaceous, Campanian age. The rocks are mostly reddish-brown sandstones, again suggesting rivers, lakes, dunes, an alluvial plain and aeolian setting under a semi-arid climate. So environment-wise, quite comparable to Barrangoyot.
And that's where the Mangurostrus fossils, now considered Bagaceratops, were found.
Exactly. What's really remarkable about Bayan-Mandahu is the fossil preservation. It's often exceptional.
How so?
You find vertebrates, dinosaurs included, sometimes preserved in very lifelike poses. It suggests they were buried incredibly quickly.
Like caught in a sandstorm or a collapsing dune.
Something like that, yeah. Rapid burial events seem to have been common there, which is fantastic for paleontologists, of course.
Yeah.
It gives us amazing insights.
Absolutely. And who lived alongside Bagaceratops in this formation. Any differences from Barun-Goyot?
Some overlap, some differences. You still find Protoceratops there. Ankylosaurids like Pinacosaurus. Alvarezsaurids like Linhenicus. Dromaeosaurids are present too, including Linharaptor and the famous Velociraptor.
Velociraptor?
Yep. Oviraptorosaurs like Marcorosaurus and Wulat-Long. And Troodontids, another group of small feathered predators or omnivores like Linhavenator, Papiliovenator, Philovenator. Again, various mammals, squamates, and also some distinctive turtles, the Nancinotilids.
So, similar ecological roles being filled, but often by different specific genera compared to Barun-Goyot. It paints a rich picture of these late Cretaceous Asian ecosystems.
Really does.
Okay, so let's try and wrap this up. Thinking back over everything, what are the main things we should really take away about Bagaceratops?
Well, I think first, its place as the small but quite significant early horned dinosaur in late Cretaceous Asia. It wasn't a giant, but it was clearly successful.
Right. Very common in its environment.
Second, the whole story of its discovery and classification, how science refined our understanding, merging several names into one species based on growth and variation. That's a great example of the scientific process.
Yeah, the synonym story is fascinating.
And third, just the environment it lived in. Getting that glimpse into those semi-arid ecosystems of Cretaceous Mongolia, filled with such a diverse range of dinosaurs and other animals.
It really helps bring Bagaceratops to life. So this small horned face, despite maybe looking a bit plain compared to later ceratopsians, it actually tells us a lot. And it leaves you wondering, doesn't it? What can studying these, well, seemingly more primitive forms like Bagaceratops really tell us about the evolutionary pressures, the drivers, that led to the huge, spectacular horned dinosaurs in North America later on?
That's the big question, isn't it? How do you get from Bagaceratops to Triceratops? What were the steps?
Exactly. And what might future finds, maybe even from those same Mongolian formations, still reveal about that transition? There feels like so much more to discover there.
Oh, undoubtedly. The Gobi Desert likely still holds many secrets about dinosaur evolution. There's definitely more of the story waiting to be found.